intensive today, we were supposed to get through 2 lessons, and then realized it's a Tuesday, so we had 20 minutes less, and that made a huge difference. So we're not only going to do 1 lesson today. We are going to go through this. We're starting our percent and ratios piece. We're going to be doing a lot of work with percents over the next 3 weeks, basically. We're going to start with a definition today. So a ratio is what? What type of comparison of two quantities which describe the same attribute? They can be written in several ways. What do you think that relationship is? No guesses at all? Nolan?
I have a reason why I'm not guessing. Usually when I guess, I'm very much wrong.
You're better than you're giving yourself credit for. If I have 2 fractions side by side and I'm going from one to the other, what do I do? Which one do I normally do? Multiply. So how do I describe that relationship? Multiplicative. So it is a multiplicative relationship. Okay? So it's a multiplicative comparison of the two quantities. Now, when we write a ratio, there are several ways to write it. I can use it in words. So 2 is a common word when we're using it. Or you can say like for every or per. There's a lot of different words I can use as a comparison. So I say the first thing, and then I say the comparison word and what I'm comparing it to. Mathematically, when we do a ratio, most of the time, we're going to use the colon. So that's showing that it's a relationship between those two things. It is called a colon, yes. Who did you have last year, Miss Singer or Miss Starbucks? Oh, good. She's good. I'm going to ask her about that. And then we can also do it as a fraction. Notice, whatever is listed first should be in my numerator. Whatever is listed second should be in my denominator. Okay? And as we'll talk about in the lesson, your order matters. You got to make sure you're putting them in the correct order. Now, when we are looking at fractions, if they are not in simplest form or simplest terms, what process do we go through to get them where they are? What do we call that? Simplified. They are simplified. I didn't know how to say that without actually using the word. So ratios can also be written in simplest terms, or the term we use is simplified. When do we simplify?
Always.
Always. What are our 4 key numbers to help us get to our simplest form? Carson?
2, 3, 5, and 7.
Good. 2, 3, 5, and 7. Check your numerator and denominator. Can they both be divided by one of those 4 numbers? If they can, you do it. Now, here's where it gets a little tricky, and this is where the advanced math, where I can have some more fun with you guys. Sometimes you'll find that one of them can be divided by 2, the other can be divided by 3, or just one of those 4 numbers. If that is the case, you need to check your second factor. The 11s are easy. So if I give you like 55 over 77, most of you should realize I can divide them both by 11, right? So then the 2, 3, 5, 7 won't get you. Just going to divide 55 and 77 by 2, 3, 5, 7? No. So normally, by the rule I've given you guys, you would say it was in simplest form. But in that case, I can divide 55 by 5, 77 by 7, then I have to check your second factor. I'll give you a hint. The ones that are really fun to use are 13s, 17s, 19s, because most of the time you aren't looking for those. 11s are easy. Those are the ones that will get you. So if I can do them by one of those 4 terms but not the other, check your second term. But 95% of the time, 2, 3, 5, and 7 will get you to the right answer. Any questions on your initial notes? Okay, let's go to our second page. Now we're going to give you a chance to practice writing the ratios. So take a look at what they've given. Write the ratio accordingly. I want you guys to do this individually. Then once you finish, you can work with the people at your table. So I'm going to give you guys about 5 minutes to knock this one out. You got 8 of them to do. Okay, let's take a look at what we've got for our comparisons. Gloves to total equipment. What did you guys get?
3 to 12. 1 to 12.
3 to 12.
1 to 3 to 12. 1 to 4 to 12.
So, what I should have seen, 3 gloves to 12 total. And then you show me how you are simplifying. So, 1, 2, 4 would have been your final answer. But here's where we're having troubles on the testing. Most of you went straight to the 1 to 4 and did not show me where you started. How am I supposed to follow your work if you don't give me the entire trail? I can't. Okay? So you've got to show me everything, guys. Show me where you're starting. Show me where you're ending up. Did you have to write it as a fraction? No. You could have written 3 gloves, 12 total, which would then equal 1 glove to 4. That would also be acceptable. Did you have to put in the labels? No, technically you didn't have to. However, I would encourage you, highly encourage you to do so, because it's going to help you keep everything straight as we go, as the problems start getting more complex. What about cleats to cones? 3 to 3. Which equals 1 to 1. Or you could have done 3 to 3, 1 to 1. That also is acceptable. You could have done it either way. What about your water bottles to total? 2 to 12. 2 bottles. 2, 12 total. So 1 bottle and 6 total in simplest form. Or in fraction, in cone format, 2 to 12, which equals 1 to 6. Make sure you're showing me where you're starting. Show me where you're ending up. I need to see the whole process. Things you wear to total equipment. Good. Should have gotten 6. 6. Wearable. 2, 12 total. Which equals 1/2. I did it as colon format, 6 to 12, which equals 1 to 2. Total the cleats. 12 total. 2, 3 cleats. So 4 to 1. Actually, I've been bad. I should have showed on each of these what I was dividing by. I did on the first one. Make sure you're showing your work, so that if you make a math error, I can follow along and see where you're making your mistakes. What about soccer balls to water bottles? Divide those by nothing. That's actually the simplest form. Cones, the things you wear. 3 to 6. Which equals, divided by 3, gives me 1 cone and 2 wearables. Back down to 1 to 2. And our last one, cones to water bottles.
3 and 2.
Can I simplify that?
Yes.
No. Because a ratio is a very special format, guys, this is one of those instances where an improper fraction is okay as your final answer. Because it is a specific thing that I'm asking you. So in this one, 3 to 2 is your final answer. Make sense? Questions on any of that? Okay, so we've got some good practice on writing our ratios. Now let's talk about the meaning. I want you guys to do this one as a table, because I want you to talk about it. We'll give you guys about 2 minutes. So let's look at it first. Ryan, you really need to stop repeating me. I actually did a pretty good job of talking. So we sorry, but that's kind of rude.
Wow.
Okay, we need to write the ratios below. Then determine if the ratios are different. Justify your answer. So if I looked at gloves to water bottles, what was that ratio? 3 to 2. So 3 gloves to 2 water bottles. What about water bottles to gloves?
2/3.
2 water bottles over 3 gloves. So are they the same ratio?
No.
Why not? They got a 2 and a 3.
3/2 is an improper fraction, while 2/3 is a proper fraction.
Okay. But it's still a 2 and a 3.
Even though it's still a 2 and a 3, doesn't mean it's the same ratio.
Why not?
Because usually with fractions, improper fractions need to be simplified.
Okay. Oh yeah? So you're comparing the value? Carson?
They use the same numbers, but just in a different order.
Does the order matter?
Yes.
Yes, the order definitely matters. If I look at them from a value perspective, do they have the same value? No. So are they different?
Yeah.
Yes. Does that make sense? So yes, your order matters. Yes, the value is different. So Ariel got the closest. She talked about, well, although Timothy was right on too, he also said you could simplify. The key is the value, guys. Do they have the same value? No. 3/2 is 1.5. 2/3 is 0.6 repeating forever. Is that the same? No. So are they different?
Yes.
Absolutely. Even though the numbers are the same, the order matters. So be careful when you're looking at ratios. Realize that that order makes a difference. Now, when we got a little more definition. A proportion shows 2. What do you think the word would be in there? In the form of an equation.
Ratio.
What about the ratios?
To 2 separate. I don't know how to explain it. It's like
Equivalent.
Okay, you're getting closer. I'll give you a hint. It has an equation in it. What's that equation have? Nolan? No. Carson? What about the fraction? I gave you a hint. It's in an equation.
2 ratios.
Timothy?
2 ratios.
What about the ratios is important?
They're equivalent. Oh, proportions.
2
Y'all are
fractions.
hitting all around it.
2 fractions that are proportional. That is a ratio from the ectoplasmatic equation.
Equal ratio.
Equal.
You said equal. Like I said, you're hitting all around it. So it's 2 equal ratios in the form of an equation. That's how you knew the equal part. Because what does an equation have? An equal sign. When I have the equal sign, that's telling me something, guys. Proportions can be solved by scaling or setting up a equation and solving. Here's where Miss McShann will have an epileptic fit if you guys tell her about this. She only wanted you guys working on the equivalent fractions last year? Most of the time. Once I change this, here's the whole key. Once there's an equal sign in between, that allows me to change what I'm doing. The easiest way to solve this is what we call cross multiplying. Mr. Chan is completely against teaching that because pedagogically it has been shown when you are looking at multiplying fractions, how do we multiply fractions? Straight across, top times top, bottom times bottom, right? Numerator times numerator, denominator times denominator. When you teach students too closely between multiplying fractions and cross multiplying, they confuse the two concepts. So I'm hoping that you guys have been doing multiplying fractions for a while now. We taught you with just using proportions last year. This year we're going to take this step to make it easier and show you how to cross multiply. So the cross products of a proportion will always be equal or equivalent, really could work.
Thank you.
But they will always be equal. So what do I mean by cross products? What I'm saying is, if I take one numerator, and this only works with an equal sign, and I multiply by the other one, I would get the same answer going the other way. So this is how we would set up our equation. We would say 2 times 24 equals 3 times x. Okay? So then to solve it, I multiply 2 times 24 and I would get 48 equals 3 times x. Just like we taught you last year, here's my x. So I need to divide both sides by 3 to get that x by itself. 48 divided by 3 would be
48 divided by 3 would be
16. You could also solve it the way we taught you last year and really stressed. How would I go from 3 to 8? Or 3 to 24? Times 8. So what am I going to do to the 2? 2 times 8 gives me, did I get the same answer? Yes. Can you do it either way? Yes. Just be careful. If you're cross multiplying, do not get that confused with multiplying fractions. If this was 2/3 times x over 24, that would be 2x over 72. Totally different. Changing that times to an equal sign changes everything. You have to be cognizant of what it is you're doing and understand why. Yes, Nolan?
Quad ratio.
What?
Equal. Oh.
Why did you think
Quad
ratio?
Oh, that's in AL, sorry.
Oh.
Equal ratios. I mean, I said equal ratios. I didn't realize Nolan was that far behind.
Mr. Moore, are we gonna do Jeopardy in this class?
Okay, now we're going to give you guys a couple chances to practice some. So there's 4 problems within here. We'll give you guys about 6 minutes to do this. Okay, on this one, a surf shop likes to keep 8 life jackets in stock for every 5 pairs of goggles. Record the ratios below. So they gave us 2 of them, life jackets to goggles. So that's going to be 8 to 5. And that should have been goggles, not Googles. The total would have been, goggles was 5. Total, I find by adding those 2 together, which would have given me 13. So normally, if they're asking specifically for a ratio, I'm going to put it in colon format. But once I start to do it as proportions, I'm going to change that into a fraction format. Because for me, fractions just work better in order to do them. So now we have 40 pairs of goggles are ordered. How many life jackets should be ordered? So they gave me 40 goggles. And I want to know number of life jackets. But we started at 5 goggles to 8 life jackets, right? How do I go from 5 to 40? Times 8. So Now I go 8 times 8, and I would get.
64.
So I heard someone say divide. Be very careful. Normally I would start with my simplified ratio, because that's going to show me how I'm going to be going. But when the problem was set up, I started with the 40 goggles instead. You have to always start where I've got two numbers, guys. That establishes my relationship. So it doesn't matter if that's on the left or the right side of the equation. Whichever side it's on, that's where I have to start, because that's the only way I know what the relationship is. Okay? Now, technically, you could have said, okay, I'm going to divide by 40 by 8, so what number would I divide by 8 to get 68? To get 8? But it's easier for most of us to think multiplicatively. So the bottom line is, they ordered 64 life jackets. I will say it is amazing. As often as I have tried to model that we answer word problems with a full sentence, we got to the quiz and there's still several of you that aren't doing full sentences. Okay, if 30 sets of goggles are ordered, how many total items should this shop order? So now we're going to use that second one. I have 5 goggles. Try to put both these in there. Over 13 total. And I know it's going to be 30 goggles. Over some amount of total. How do I go from 5 to 30?
6.
Times 6. So I'm going to do 13 times 6, and I would get 78. So they will order a total of 78 items. Did any of you solve that one differently?
No.
Is there another way I could have solved it?
Yeah, maybe.
How, Danny?
I said Austin, I know you said maybe.
I didn't say Shane, I said Danny.
What? You divide 35.
And then
One.
6.
Could have cross multiplied. I could have gone and said 13 times 30 and then divided it by 5. I would have gotten 78. So 13 times 30 would have given me 390 divided by 5 equals 78. Where cross multiplying honestly works better is if the numbers don't work out well. As long as I've got an easy one to spot the relationship, I'm going to do that first because it's easier. If I don't see an easy number, that's where cross multiplying comes in as a good backup. Doesn't mean the math is going to be harder. You're going to test your math skills, but it gives you an easier way than trying to figure out some portion of a number that's going to work for your relationship. Okay, let's do our next one. This one should be relatively simple. Just one question. I'll give you guys 1 minute. One key, make sure you're marking your text, guys. The ratio of creamy to crunchy peanut butter jars on the grocery store shelf is 5 to 3. There are 18 jars of crunchy peanut butter. What is the total number of jars of peanut butter on the shelf? So they gave me 5 creamy, 2, 3 crunchy. But then they said 18 crunchy to total. So how did you guys solve this?
The thing you did on the first one.
Nolan?
To like see what they multiply the 5 creamy by to get the 18, but it doesn't multiply anything.
Maybe because it's crunchy?
That would be a lot.
Oh, you mean marking your text can make a difference?
3, 18.
Guys, I will add in, the other thing you should do is add these labels before you do anything else. Because if I add the labels, would I make the mistake that Nolan just admitted to?
Maybe, maybe not. Most likely, no.
If it's 18 crunchy, where does that go?
On the bottom is denominator.
On the bottom. Can labeling it help you put the numbers in the right spot? Yes. Does it get really difficult if you put the number in the wrong spot, Nolan?
Yes.
Yes, it does. But if I had it in the right spot, is this easy?
Yes.
What do I do?
Times
Times 6. So, what was my answer?
48. It's the total. I said that.
What was the answer? Constant?
Yeah, then what's the add?
Oh, so I need to add them together because it said total. Did it ask for the number of creamy?
No.
No. So anybody that answered 30, were you correct?
No.
No, because did you pay attention to the question? No.
Yes.
You guys, at what point will it get through to you that marking your text will help you? Especially if you'll pay attention to what you mark.
High school.
Probably. At least it's the way you're going, Peyton. So, there is a total of
48.
48 yards.
Wow. Yeah.
I learned
I
stuff
didn't even-
every day.
Yeah, but I didn't cross it. That's so smart.
Does this make sense? Could I have done it a different way?
No, I don't know.
Could have gone both ways? What was the question about, though?
What is the total?
Total. Could I have figured out the total in the ratio to start with?
Yeah.
Yeah. Could I have said, oh, that's 3 crunchy to 8 total? Could I have done that? Yeah. Then could I have said, okay, well, it's crunchy to total, because I always put in my labels first, and now I know it's 18 crunchy. How do I go 3 to 18? So, could I get right to the total? Did I have to do it this way? No. Either way, it's fine, guys, as long as you are showing your work. Because Ryan, can I figure out what you're doing if you don't show your work? No. So is it important to show me where you're starting and where you end up?
Yes.
Absolutely. Does this make sense?
Yes.
Okay, let's try another one. Okay, they travel by plane, average speed 387.5 miles per hour for 2 hours, and average speed of 56 8/10 for 1 2500ths. What was the total distance in miles she traveled? So this one, to actually set it up properly, means understanding what MPH stands for, which is 387 5/10 miles per hour. But I'm doing that for 2 hours. How do I go from 1 to 2? Times 2. So what am I doing to this? Times 2. So I take 387 5/10 times 2. I've got 1 decimal. Now I'm doing 3,875 times 2 gives me 10, 15, 17, 7. Put my 1 decimal. So that means you went 775 miles by plane. My next part, 56 8/10 miles per hour. But now it's 1 2500ths hour. So how do I go from 1 to 1 2500ths? No, we multiply. We never add in proportions. Times 1 2500ths. So now is where the math gets a little more fun. So I've got 56 8/10 times 1 2500ths, meaning I got 3 decimal places. So I write the 3, now I'm just multiplying. 568 times 125. So that gives me 40, 34, 28, bring the 0, 16, 12, 13, 10, 11, bring 2 zeros, gives me 8, 6, 5. Now I add up my columns. 0, 4. Did I do something wrong? What did I do wrong? Oh, that's a 6. That's why. Ooh, couldn't read my handwriting. This was a 6. Makes that a 10. Makes that 16, 20. Gives me 4, 10, 11, 5, 6, 7. I put in my 3 decimals. What do I get? 71 miles. So she did 775 by plane, 71 by car, and now add those together. Gives me 0, 6, 14, 8. So she traveled 846 miles. Got the decimal there. Make sense? Okay. The ratio 3 to 8 is equivalent to the ratio 24 to 64. Place a check mark next to any proportions that show this equivalency and explain your thinking. Okay? Now, again, you have to think about it proportionally. How am I going from one side to the other? And did I do the same thing on both? So, I like to start on the lower side. So how would I go from 8 to 24? Times 3 is 3 times 3, 64? No, so that one was not it. How do I go from 8 to 3? You can, but it's not very easy. Is that times 8/3? No, it actually got bigger. So if I got smaller here and bigger here, does that make any sense? No. How do I go from 8 to 64? Times 8. How do I go 3 to 24? Does that one work? So I put a check there. How do I go from 8 to 3?
You're going down, so that's all that's clear out.
I'm sorry?
Oh, no, you divide. You subtract. You multiply.
Divide. So it's getting smaller, so I would divide, right?
Yeah.
What would I divide by?
3 or 1 and a half. 8 divided by 3 plus 1.
Hello.
64 divided by 3 is 72. I'm not
Technically, I could multiply, right?
Yeah, you can multiply by
I can multiply by 3/8. How did I figure that out? Because how would I go from 8 to 3? Well, I need to get a 3, right?
Yeah.
I got to get rid of the 8. How can I do that? Multiply by 3 and divide by 8.
I don't understand.
What's 8 divided by 8? 1. What's 8? 1 times 3. So, did I get from 8 to 3 by multiplying by 3/8?
Oh, yeah.
Yes. So I multiply that by 3/8. What do I do to the bottom?
Do the same.
Times 3/8. So I do 64 times 3/8 means I put this over 1. What's 8 and 64? What factor do they have in common?
Oh.
8. I can divide them both by 8. That makes that a 1, that an 8. What's 8 times 3?
24.
What's 8? 1 times 1?
1.
What's 24 times divided by 1? So, did that work?
Yeah.
Yes.
That is cool.
Now, could I also cross multiply?
Yes.
Yes. 3 times 64, 8 times 24. I do recommend when you're cross multiplying, especially when I'm looking at equivalencies, start on the bottom number and write them on top. Because this will also show you which one's bigger or smaller. So 3 times 64 would give me 12, 180, 192. 24 times 8 would give me 192. 64 times 8 is going to give me 32, 512. 3 times 24 is going to give me 72. Are those the same? No. 3 times 24 is going to give me 72. 8 times 64 is going to give me 512. Are those the same? Nope. 64 times 3 is going to give me 12, 192. 24 times 8 is going to give me 192. Are those the same? Yes. If they're the same, they're equivalent. That's where the cross multiplying becomes really easy.
Ratio 3 to 8 is equivalent to ratio 24 to 64.
Yes.
So we can go ahead.
3 to 24 is to 8 to 64. Is that the one you said, Danny?
Yeah.
Yes, that's equivalent.
Yeah, because it literally tells you on the top.
Literally tells you.
It really doesn't, because this one says 3 to 8 and 24 to 64. These are different than both of those. Because your order does matter. Okay, a small university enrolls in-state and out-of-state. The number of students enrolled in the most recent class was 243. The school reported that it enrolled 7 in-state students for every 2 out-of-state Students. How many in-state and out-of-state students were enrolled in the freshman class? So what do you know? Yes.
I know 7 in-state students for every 2 out-of-state students.
Okay, so 7 in-state, 2 out-of-state. What else do you know? $243 total. Okay? So what do you need to know? Number in state and number out of state. So given that, how could I work it? For my in state, I could say I have 7 in state. Do I know how many total? Yeah, 7 and 2, right? 9 total. And I know it's going to equal 243 total. But I don't know my in-state, do I? So, I can divide 243 by 9 to figure out what I'm multiplying by. 243 divided by 9, that's going to go 2 minus 18 gives me 6, 7, 63. So, I multiplied by 27, so guess what I'm doing to the 7? Times 27, 7 times 27 is going to give me 49, 14, 189. Okay? What about for the out-of-state? Then all I'm going to do is change those numbers, make it 2 out to 9 total. And I know it's good. Did anything else change? No. The only thing that changed is that one number on top. I'm still multiplying them both by 27. So I do that times 27 and I get 54. So there are 189 in-state and 54 out-of-state students. Sorry you guys didn't have the time to work through that one on your own, but we got to get the recording finished. Does that make sense? Any questions on that one? How we set it up or what we did? Okay? Look at our next. Oh, that was it. I thought we had another one. Okay, that means your homework for tonight.
No, Amy's better than me.
Your homework for tonight is just the one sheet. Initially, we had said that there were 2 in our A1 class, but God, it was a Tuesday. You have less time. For you guys, I'll hand out the sheet right now while you guys start packing up. Good luck.